Tetraphenylporphyrin, abbreviated TPP or H2-TPP, is a synthetic heterocyclic compound that resembles naturally occurring porphyrins. Porphyrins are dyes and cofactors found in hemoglobin and cytochromes and are related to chlorophyll and vitamin B12. The study of naturally occurring porphyrins is complicated by their low symmetry and the presence of polar substituents. Tetraphenylporphyrin is hydrophobic, symmetrically substituted, and easily synthesized. The compound is a dark purple solid that dissolves in nonpolar organic solvents such as chloroform and benzene. Synthesis and structure. Tetraphenylporphyrin was first synthesized in 1935 by Rothermond, who caused benzaldehyde and pyrrole to react in a sealed bomb at 150 degrees Celsius for 24 hours. Adler and Longo modified the Rothermond method by allowing benzaldehyde and pyrrole to react for 30 minutes, refluxing propionic acid open to the air. 8C4H4NH plus 8C6H5CHO plus 3O2 2422 plus 14H2O. Despite low yields, the synthesis of H2-TPP is a common experiment in university teaching labs. The conjugate base of the porphyrin, TPP2-, belongs to the symmetry group D4H, while its hydrogenated counterpart H2 is D2H. Unlike natural porphyrins, H2-TPP is substituted at the oxidatively sensitive meso-carbon positions, and hence the compound is sometimes called meso-tetraphenylporphyrin. Another synthetic porphyrin, octaethylporphyrin, does have a substitution pattern that is biomimetic. Many derivatives of TPP and OEP are known, including those prepared from substituted benzaldehydes. One of the first functional analogues of myoglobin was the ferrous derivative of the picket fence porphyrin, which is structurally related to Fe, being derived via the condensation to nitrobenzaldehyde and pyrrole. Sulfonated derivatives of TPP are also well known to give water-soluble derivatives, e.g., tetraphenylporphyrin sulfonate. 4SO3 plus 422 plus 4H2O complexes. Complexation can be thought of as proceeding via the conversion of H2-TPP to TPP2- with fourfold symmetry. The metal insertion process proceeds via several steps, not via the dianion. The resulting complexes are symmetrical with simple NMR or EPR spectra. For example, Cu has D4H symmetry. The corresponding ion complexes are more complex owing to variable oxidation states and coordination numbers. Well-studied derivatives include the ferric compounds, e.g., FeCl, and the oxide, Fe2O, and ferrous compounds, e.g., FeCO. Optical properties. Tetraphenylporphyrin has a strong absorption band with maximum at 490 nanometers and 4 weak bands with maxima at 515, 550, 593 and 649 nanometers. It shows red fluorescence with maxima at 649 and 717 nanometers. The quantum yield is 11%. Applications. H2-TPP is a photosensitizer for the production of singlet oxygen. Its molecules have potential applications in single-molecule electronics, as they show diode-like behavior that can be altered for each individual molecule.